Okay, this is lesson 5 in chapter 1. We're going to be talking about negative exponents. So I want to remind you about the activity we did, the real world link in your book, where we talked about 10 cubed is 1,000, 10 squared is 100, 10 to the first is 10, 10 to the 0 power is 1, and you start to see that this is dividing by 10. So obviously if we go from 10 to the 0 being 1, if we divide by 10, as we go down, if we reduce this by 1, the exponent gets reduced by 1, so it's negative first power, and this is divided by 10, so it's 1/10. Divide by 10 again, and we have 1/100th, and divide by 10 again, we have 1/1000th. But I want you to see this in another way. So I'm going to show this same thing on the next slide. 10 to the 0 being 1. 10 to the negative 1, 1/10, etc. We just had that. And then in the book they show that you should think of this as 1/10 like this, 1/100th, 1/1000th. But I want to add an additional step here and talk about the fact that we can jump immediately from 10 to the negative first, and we can move that 10 to the first into the denominator from the numerator, and it becomes positive. This is a very powerful thing when working with negative exponents. Basically, if you move it from the denominator to the numerator, the sign of the power changes. If you move it from the numerator to the denominator, the sign changes. So 10 to the negative first becomes 1 over 10 to the positive first. 10 to the negative second becomes 1 over 10 to the positive second. 10 to the negative third becomes 1 over 10 to the positive third. This is a very powerful thing when doing problems with negative exponents. You'll see that very clearly in a minute. So, in example number 1, we're supposed to write the expression using positive exponents. It's important to keep in mind what your directions are here. So 6 to the negative third, we just talked about, we can move it to the denominator and it becomes positive, so it's 1 over 6 to the positive third. Now we don't take 6 times 6 times 6 and put that number in here because they didn't ask for that. They wanted in terms of positive exponents. So you see this relationship. Example number 2, a to the negative fifth becomes 1 over a to the positive fifth. Got some practice to do. Please do problems A through D. Example number 3, we're going to write expressions now using negative exponents. So we take 1 over 5 to the positive 2 power, and we're going to move it from the denominator up to the numerator. We're not going to put the over 1. We don't need it. And it just becomes 5 to the negative 2. Example number 4. Same thing here. Only in this case you need to see that this is a square, perfect square. So we can change it to 1 over 6 squared. Now we can move that up into the numerator and make it 6 to the negative 2 power. Press pause and do letters E through H. Example 5. A human hair has a diameter of 1/1000th of an inch. Okay, we remember it's the tens, hundreds, thousands. So that's 1,000th of an inch. So we can write that like this, 1 over 1,000. Our instructions, however, are to write it as a power of 10. So if we have 1 over 1,000, we can immediately see that that's 1 over 10 cubed, and then change that to 10 to the negative third. And because I preach it to you guys, I'll put my comma in there. Always have commas with numbers with more than 3 digits. Press pause and please do letter I. Example number 6. Now we're asked to simplify, so we're going to get an answer by the time we're done. We're going to use our laws of exponents. 5 cubed times 5 to the negative fifth is 5 to the 3 plus negative 5. Or I would just write 3 minus 5 in this case. So this is the 3 minus 5 power. And that, of course, is negative 2. And then we can make it positive by moving it to the denominator. Becomes 1 over 5 squared, which is 1 over 25. However, there's another way to look at this from what we talked about at the very beginning of this lesson. We can move this to the denominator in order to switch the sign. So we can take 5 to the third times 5 to the negative fifth and write it as 5 to the third over 5 to the fifth, because it'll become positive when we move it into the denominator. Now we can see this as 5 squared in the bottom. If you need to see that, of course, we could do this. 1, 2, 3 over 1, 2, 3, 4, 5. And of course these three would cancel out. We'd have 1 over 5 squared, or 1 over 25. This is a really good way to learn to do these. It's really powerful. Example number 7. We have w to the negative 1 over w to the negative 4. This is the perfect example of doing it the other way, but we'll do it this way as well. W to the negative 1 minus negative 4 is like negative 1 plus 4. Negative 1 plus 4, of course, is 3w cubed. Or we can just move this to the denominator and this to the numerator, and the negative 1 becomes positive 1, the negative 4 becomes positive 4. Now we have w to the 4th over w to the 1st, and we got pretty good at doing these in the last couple of lessons. We should immediately see that's w cubed. Please press pause and do letters J through M. Here are your solutions to Lesson 5, Chapter 1, the letter problems. First of all, your instructions for the first segment are to write the expressions with positive exponents. So we're going to look at 7 to the negative 2. And remember, we can move it into the denominator and make it positive, and then it becomes 1 over 7 squared. It's that simple. Letter B, we have b to the negative 4th. Move it into the denominator, it becomes positive, so we end up with 1 over b to the 4th. Letter C, remember any number to the 0 power is 1. 5 to the 0 power is 1. Letter D, m to the negative 3 equals 1 over m to the positive 3. Now we're going to switch and start writing our expressions using negative exponents. Again, to build your ability to recognize that we can just move it from numerator to denominator or denominator to numerator in order to change the sign. 1 over 8 to the positive 3 is like saying 8 to the negative 3. F, 1 over 4. Now in this case, they want you to recognize that this is a perfect square, so 2 to the 2nd power is the same as 4. Rewrite it as that, and now you can see that you're going to be able to write that as 2 to the negative 2 by moving it to the numerator. Letter H is 1 over 27. Another one we need to be able to recognize. It's a perfect cube in this case, 3 times 3 times 3. So it's 1 over 3 to the 3rd power, and we can change that to 3 to the negative 3 to express it as a negative exponent. Letter I. First of all, make sure that you had 9 zeros here, and they want you to be able to write this using a negative exponent as a power of 10. So I want you to remember that we did a problem earlier, one of our example problems, where we had 1 1,000th. Now in this case, I don't expect you to count out and say that that's 1 over whatever. I'm not too concerned that that's something that you need to be able to do. What I'd rather you be able to do is use a sample problem like we've already done and recognize that this number, 0.001 or 1,000th, ended up being 10 to the negative 3. And I want you to notice that we moved 3 places, and that should give you a hint here. Okay, notice that 1 1,000th or 0.001 ends up being 10 to the negative 3. Therefore, how many places did we move from here to here? And if you count that all up, we have moved 10 places, so it only makes sense that this is 10 to the negative 10th. And what I would like you to do in your calculator, because I want you to understand you can check these, take your calculator and write 10 to the negative 3, hit enter, and you will get this number. Take this number, 10 to the negative 10, hit enter, and count up the zeros, and you will find that number right there. So these are problems that can be checked by you, is what I'm telling you. Letter J, our instructions are to simplify, so we have 3 to the negative 8 times 3 squared. We can use our law of exponents and say that that means that it's 3 to the negative 8. We're multiplying, so it's plus 2, and that equals 3 to the negative 6, and that is, of course, 1 over 3 to the 6th. But we are simplifying, so we're not done yet. 3 to the 6th is 729, so it's 1 over 729. The alternative method, the one that I've been showing you, is we can move this to the denominator. It becomes positive. Now we have 3 squared over 3 to the 8th. That means we could cross off 2 of the 3's on the top. That would cross off 2 on the bottom, and it would become 3 to the 6th. I shouldn't say bottom, I should say denominator. 1 over 3 to the 6th is 1 over 729. Same answer. Some of you will find this easier, some of you will find this easier. Use what works for you. Okay, 11 squared over 11 to the 4th. We can imagine canceling out 11 times 11 on the top, 11 times 11 on the bottom. There would still be 2 left, so we would have 11 squared. And 11 times 11, you should all know, is 121. 1 over 121. L, n to the 9th times n to the negative 4th. That would be n to the 9 plus a negative 4. That's 9 minus 4. That's 5, n to the 5th. Or we can move this into the denominator, and we have n to the 9th over n to the 4th. And that, of course, cancels out to n to the 5th. Letter M, b to the negative 4 over b to the negative 7. That's b to the negative 4 minus negative 7. We're subtracting because this is division here. Okay? And that minus of minus is a plus, so negative 4 plus 7 is positive 3. This, I think, is definitely the easier way to go here. If you move the b to the negative 7 to the numerator, it becomes b to the 7th. Move b to the negative 4 to the denominator, it becomes b to the positive 4. And now we just have 7 over 4. 7 minus 4 is 3. B to the 3rd power. Please do the guided practice.